All right, welcome everybody to our webinar this morning or this afternoon, depending on where folks are. I hope everyone is very excited to be here. I know that I personally am really excited for what we're going to be talking about today. We've got Dr. Peter McCaffrey and James Weatherhead, both from the University of Texas Medical Branch. Welcome to both of you. Dr. McCaffrey, you just want to tell us a little bit about who you are and why you're here, and James as well.
Yeah, thanks for having me. So my name is Peter McCaffrey. I'm a pathologist at University of Texas Medical Branch. I'm also our Chief AI Officer for the health system and enterprise. So my job, broadly speaking, is how can we use AI in healthcare and what amounts to efficient ways for us to try new approaches in AI in a way that's safe and efficient for us. And again, appreciate your time. Share some cool stuff. And James, I'll let you give it a try yourself.
Hi, everyone. I'm James Weatherhead. I am MD PhD here at UTMB. Dr. McCaffrey is my PI, and I've been working with him on a bunch of AI projects. And today we're excited to show you what we've done.
Awesome. Thanks, y'all. So, Dr. McCaffrey, just before we start, I know folks are eager to see some demos, and we want to get to those pretty quickly. But could you just give us a little bit of a background on UTMB, what y'all are, and what you do, and as well as kind of what brought you to want to use AI for some of the challenges that you were facing?
Yeah, I'd say we are kind of your classic large academic medical center. We're a fairly complex operation. We have 4 main campuses in the Houston Metroplex, Houston and south down to the coast, headquarters in Galveston, Texas. We have about 1,000 to 1,100 beds across our campuses, about 1.5 million patient encounters every year, about 40,000 discharges. So busy academic medical center. We do everything from primary care to neurosurgery to critical care, a school of nursing, school of medicine, school of public health, graduate schools of science, lots of activity going on there. And then we're home to one of the few BSL-4 labs, so we can do work on exotic things like Ebola as well. So we do a lot of different things. And so our needs for AI are somewhat classical. Like we want to make healthcare better, more efficient, but also we want to make operations more efficient because we have a lot of operations and a lot of complexity. We think AI can help us broadly. And so we look to how can it make our patient diagnostics quicker? How can it make our billing workflows quicker? How can it help us find things easier? These kind of basic steps. But one day we think we can make even a place as big as us a pretty efficient operation with AI, and it's our goal to eventually get there.
Cool. So I'd love to dig into some numbers about that because I know that you guys have seen some pretty amazing results. And can you talk about a little bit of the specifics around kind of where you started and after you built some of these AI tools, like where you ended up in terms of how many more patients you were able to serve and things like that?
Yeah, absolutely. So UTMB is, I think, unique in the fact that our pathology department houses a lot of our AI, certainly not all of it, but a lot of it. And we have a center in there for diagnostics that's really motivated to push the envelope for how AI can benefit patients in practice. So we started applying in production AI as a co-pilot to do interpretation in the domain of pathology. So we'll talk about talks in a second, but we see 2 kinds of benefits. One is final outcome, like being able to write interpretations in seconds, and when they would have taken 15, 20 minutes a case is a huge just efficiency and throughput gain. It also lets us do them more often for more people, and we think that's a general public good for patients overall to get more of that clinical reasoning all the time. But also just when it comes to wanting to do AI, how efficiently can you try stuff with AI? Is it a year every project you have, or could it be faster? There's lots of things you want to experiment. You want to be able to do it in an efficient way with regard to time, money, and overhead. So a big piece of that is how do we make that quick? And we've also seen that sort of like quick prototyping approach takes something that could have been easily many months to a year of a one-off project into a few days to bring an application to life, put it in the hands of users, and see what they think about it and get real-world feedback.
Cool. That's awesome. And, that's, I think a sentiment that we've talked about before that we share at Retool as well. And one of the reasons we're excited to see what you've built today. So if we could, I'd love to just dive into, the first one of the apps that you all built. Just give us a little bit of an overview of kind of what the problem was, what you guys experimented with. And then if we could check out the app, that'd be awesome.
Yeah, totally. Let me talk while I'm walking you through. So here is our Retool homepage. I'm going to talk about auto talks in particular. So by the way, we host this all on Retool self-hosted inside our network. In that way, we kind of abide by all of our HIPAA requirements and our safe use. That's a great advantage to be able to do that. These are all fake patients, by the way, just so you know. But the toxicology workflow is essentially, I as a pathologist see a list of cases I need to interpret. And I need to look at, for a given patient, what is their meds they're on, what is the urine drug screen results they have. Then I write an intern. I explain that. Well, this makes sense. This doesn't. Consider this. There should be on that. And the traditional way is it's all by hand. I have to go find that information, put it in a single place, copy it into place, and then think about it and write that interp. When really what I'd rather do is review the interp. It's not a very good use of my time to compose it from scratch every time. So in this case, I log in as a pathologist and I see a case list where GPT has already found that there's an order to do an interp, gotten the requisite information from our EMR, the meds and the results, and drafted the interp. So here is John Smith or Peter McCaffrey, again, made up people. But you could click, for example, on John Smith, and you go into their evaluation card, and you can see that we surface the meds they're on, and we surface, the results, the drugs they test positive for, which should be tramadol and its metabolite, and the meds they're on, which is tramadol. And so in this case, that would make sense. And so AI has already written, yes, it's positive for tramadol and its metabolite. This is consistent with the prescribed meds. I can copy it to a clipboard, and I can go ahead and paste it into Epic. I can also opine on whether I think it was a good outcome. I can say, yeah, it's not the best. It's not very accurate. It's fairly complete, too wordy or whatever. And I can record this in a database, and I can post my feedback. So we like this because this changes my workflow from writing to seeing everything in one pane, like data here, and the draft. I can click on it. I can, agree or disagree with what's there. I can copy, paste, and Epic, edit, and file. So my work is more efficient. But when I go back to my case list, I can also keep track of what model, so GPT-4, being used for these patients, and what version of the prompt. We might iterate the prompt over time. And every time people go and they fill in a feedback about something like an overall score and accuracy, we just use some aggregate functions in the database to go over and recalculate what could be a mean overall score for these patients enter. So we can track the progress of iterating while also doing this as a clinical workflow. So right now at UTMB, you log on here to AutoTox, you pick a patient in the list, you go to evaluation card, you review, you copy paste, and you sign out. So the fact that I can do that direct workflow in 20 to 30 seconds versus, at least 7 or 8 minutes is a multiple order of magnitude at least over my efficiency to do it. It means I can do it for more people. But it also means that my feedback in doing it persists over time to let us improve that process for the next case and the next case and the next case. As you can see, we've up versioned the prompt to make it better in light of feedback.
That's awesome. And so one question I had there that I wanted to dive in on a little bit was when you leave that feedback there at the bottom of each one of these evaluations, is the GPT model ingesting that, or are you just using that internally to say, okay, we've gotten this feedback, we want to improve our next version of the prompt and use the feedback, the aggregate feedback we've gotten to write a new version of the prompt and deploy that?
It's the latter. So we just keep this as analytics, and we say, okay, this is the general kind of feedback people gave for prompt 1, that it was accurate but not very complete. Maybe it didn't mention, a certain metabolite that it should talk about. And we just manually take that into account and say, okay, when we write the next prompt, we're going to call out, you should include mention of this. It's very human in the loop, but it's still very ergonomic to be able to think about it that way with aggregated feedback.
Great. And I think one of the things that I really like about this is, the all of my main use cases for AI, and it seems like y'all's too, are kind of a first draft, very much a take all of the information, aggregate it, and it's cool to see how that's allowed y'all to move a lot faster. And so, have you found that the using GPT-4 and kind of iterating on this prompt a couple times that it does at this point hit most of what y'all want to capture from the first draft of this?
I would say that through a couple of basic techniques like few shot prompting and just more explicit instructions, it's probably 96% of the time you don't need to touch anything about it. And by the way, that's very good. Nothing is perfect, and we don't assume it needs to be. It's just the incremental efficiency that you shave off of doing this from scratch every single time accumulates to quite a lot.
Awesome. Well, cool. That's really cool to see. I know you've got to run here shortly, so thanks for joining us and showing us AutoTox. But
I appreciate it.
All right.
And you're in good hands with James, and thank you all for your time. See ya.
Cool. Awesome. Well, James, thanks for still being here with us. I know we've got a couple more apps we want to dive into and show a couple more demos. Where do you want to start with those?
Definitely. I want to start with pharmacogenetics if I can. So I don't know if everyone knows here what pharmacogenetics is or pharmacogenomics, but essentially we all have enzymes in our body, and we all break down pharmaceutical drugs that we ingest, and there's actually differing degrees of how much you can break that down, and we're actually starting to map that to patients' genomes. So this dashboard that we created, you can come in here, we can select a HIPAA-compliant patient. Let me just get out of that. So when you come in here, we can see the orders, the barcode of the order, the testing timeline, when it was sent, the kit registration, yada, yada, yada. And if we go over to variant detail, once the test has been processed, we can look at, okay, let's look at the genes, let's look at the variants of the genes, and let's look at where the variant is present in the assessment. So then we can also pull in one-ohm interpretations of these changes in your genotype, meaning how are you going to digest or metabolize the drug differently. And what we've done with this is, on the last step of this, we say whether it's a top 100 drug, and we say the brand name, and we have recommendations based upon databases that we've pulled this information from. And it creates comments based upon each metabolizing status that you have. For example, let's look at this one. This person has this genotype and this gene, and for this drug, they're a poor metabolizer. So the recommended start for this patient would be perhaps a lower dose. And luckily, this drug is not a top 100 drug, but you can start to see that drugs that are very commonly taken by patients, if they can't metabolize it, that could have very detrimental effects to their health. So then these comments are all based upon each one of these cells, and we can actually drag these comments up, down, however we want to organize it. If we come down a little bit further, just to show you here, this is all the comments in this area. All the comments will be in an AI draft that we can put on Epic after we're done. We also have the ability here to use the Fire API for Epic, so we can just automatically retrieve from Epic the patient's current medications that they're taking. And yeah, that's the second project that we've been using Retool for. I can go on to the third one if you like.
Cool. Yeah, I just have a quick question. Like, I would love to get a little bit of better sense of like the before and after of this process. So, like where specifically kind of does AI come into play here? Is that what's making the kind of comments and recommendations, or like what would the workflow kind of pre this app look like, and how does this make y'all more efficient?
Yeah, so previously, well, personally, I've never gone to a physician and they've told me my pharmacogenetic status of drug metabolizing. I don't know if you have, but I certainly
No, me
haven't.
neither.
So it's quite a new field, and with new fields, there's consistent data and literature upgrades and publications. So what this helps us with is that it helps us bring in a lot of data through APIs and process that with Llama Index, which we could talk about a bit later. And that helps us to inject into an LLM for interpretation. Okay, this is the genotype. This is what the recommendation is based on this metabolizing status. And that process is just automating the whole searching the internet for what does this genotype variation mean? What is the recommendations for that? So we're taking a very manual process that would oftentimes take physicians many, many hours if they don't have the right tool. This just streamlines it, and yeah, it turns something that would take many hours, if not weeks, manually into less than 5 minutes, I would say. So it's quite a big change. And also, pharmacogenomics is such a new field in and of itself. So automating something that's so new is it's going to be so helpful for people's health.
And did you find you had trouble like getting, because it's so new? When I've done like built AI tools like this, I found that if I'm working with a new like type of data or something that's not really in the training set, it sometimes has difficulty like providing a like good answer. Did you find some of those difficulties here, or how were you able to get around this being a relatively new field that may not know a lot about?
Yes, that there is quite a lot of issue with that. So we have to really pick our data where we're bringing information from. For example, you can see here that we have. Whoops, can you still see my screen? We have HGVS-MM, which is essentially the Human Genome Variation Society nomenclature. It's quite a robust data set. There's also something in Holland called GKB, I believe it's called. And the problem is that we have to, all the information that we're bringing in, we have to give it to physicians at our school or at an institution and say, is the scientific rigorousness of this information enough to be giving patients feedback on this? Especially with healthcare, because you have to look at, okay, how did they determine that this variation of a gene is causing this metabolizing status, for example? And that is not really an agreed upon standard thing. For the previous app that we just showed with Autotox, those are quite structured values. You either have X amount of hydrocodone because you're taking a drug that has a metabolite, hydrocodone. But with this, it's more nuanced, because when we get into the genome, it can become as individualized. Every individual is unique at the genomic level. And essentially, it's dangerous to make broad-based statements. But luckily, we haven't been using vast data sets. We've been using HGVS, and then we've also been using OneOme for the interpretation, which are very well respected within the medical field.
Great. And how does we've been talking about human in the loop. How does the human stay in the loop in this particular workflow?
In this workflow, that the draft interpretation doesn't get pushed to Epic unless a physician has read it and gone through all of it. So the human in the loop would also, as we saw earlier, we can store the prompts and the outputs into a database, where if, for example, the physician didn't like this draft interpretation based upon these variations in the genes, they could submit that to the database and be like, this is the reason why I don't think this prompt worked, because this output looks like this and needs to be more like this. And like Dr. McCaffrey said, eventually later down the line, we can apply analytics to that and just improve our prompt engineering as we go along. But right now, this is all human approval before we submit to records.
Cool.
Yeah,
that's great. And I think, that's at least what we're seeing too on our side, is like, that's where AI is most powerful at the moment. And we'll get into this a little bit later too, but when it can kind of be the first draft of things, but a human can look it over and say, this looks good, or we need to kind of iterate on this some more. So that's great. Yeah. Appreciate you showing us this. And I think you got one more for us if we want to dive into that.
Yes. The next one is a little bit different from what we've shown you already. This app that we created, it was essentially an app that allows the legal department at UTMB to look through 1,052 PDFs of legal documents across UTMB and some UT Austin PDFs as well. And what this does is, I can just show you here what it does. So what it does is you can come in and you can click on, we've ranked it here, but essentially what this does is it compares contradicting legal statements among 1,052 legal statements. So the problem in medicine is that, for example, let me just show you an example. This is the best way to do it. So as you can see here in this document, Healthcare Epidemiology 01.19, it says on page 18, it states that the duration of precautions for mycoplasma pneumonia is duration of illness, while on page 17, it states that duration of precautions for mycoplasma pneumonia is duration of hospitalization. So we can see that here is a contradicting view within the legal documents that would often take lawyers, if ever, if you think about it, because how is anyone supposed to keep 1,000 PDFs in context in their head unless they have maybe like an Excel spreadsheet where they're command F-ing things? And even then, it's like you have to be exact with the wording. What AI, what this LLM is allowing us to do with Llama Index and embedding and vectorization of this content in higher dimensional space, it allows us to find the contextual semantic meaning of our queries and retrieve information that is very specific to that. We can go a bit more into those details. Sorry, I went a bit in depth there. But what I'm trying to say is this app that we created allows the legal team to find these contradictions in legal statements, and then we can push it to them. So these are the flagged items that we're currently going through that the legal department needs to work out. And once it goes to QC, they push it to be resolved if it needs to be. And we can see here we have this rank. And what this rank is, it's from 0 to 10. So we're only displaying, I believe, 7 and above at the moment. But as you can see, we still have quite a number that are 7 and above. The way that we were able to come up with this ranking system is that we didn't implement something downstream with a prompt in the beginning. What we did is we did the entire pipeline, and then at the very end, we said to the LLM, okay, based upon everything now, rank the contradictions from a scale of 0 to 10, with 10 being the worst. And that seemed to be much better than trying to bake that into the initial system prompt. So yeah,
Got it.
you have any other
Very
questions?
cool.
Yeah.
Yeah, I would love to. I would love to know how often, like again, like the what you guys are seeing in terms of the rate of false positives, in terms of it pulling, data from these different documents, because that's something that we see with a lot of our larger enterprise customers is they want to use RAG, retrieval augmented generation, but sometimes the models still do like hallucinate a bit, and I would love to hear more about kind of how you guys handled that, or if that was a problem.
Yeah, hallucination is definitely an issue. And also, one of the things that we did to make it better at retrieving information was that I'm sure you know the way you embed the material, how many dimensions you decide to use. So traditionally, most people, I believe, today are using around 500 dimensions for whatever corporate they're using for their AI model. But for us, we went to 3,000 dimensions, which allows what that means is that 500 you can capture broad concepts and broad topics, and you can search, but you search broadly. When you have a more granular, more dimensions embedding model like we did for this, because obviously we want to be able to query very, very precisely exactly what it is that we're looking for. The larger embedding models seem to do a lot better for reducing hallucinations and genericness of the outputs.
That's great.
Yeah.
And do you have some sense for like how this has been received on the legal side? Like, what kind of efficiencies are they seeing? And I
Yeah.
know you mentioned like some of these things may have never been found, but
Yeah.
what have you all seen in terms of like time savings and just efficiency improvements from their side?
Well, Dr. McCaffrey is mainly the one communicating with them, but I have heard great things on their behalf because of just how much time it saved them, honestly. I think these tools are showing us that it's not going to replace us as quickly as everyone thinks it might. I think it's going to be, in fact, an adjunct tool for most people's jobs that's just going to improve the quality and efficiency of what we do. And I think overall they've been very receptive to this. This is one of our best performing apps and most used, actually.
Cool. That's great. And so I think with that in mind, like I'd maybe love to dive a little bit deeper into, we mentioned a lot of tools. We talked about retrieval augmented generation. We talked about Llama Index and Retool as well. And so I would love just maybe a high level overview for some of the builders on this call,
Mhm.
of like how the different pieces come together, and where Retool fits in, where some of the other tools fit in. And that would be really helpful.
Yeah. Do you want me to stop sharing my screen, or I can keep it on the screen? I can just
Yeah, let's just keep it up while we talk through it a
Okay.
little bit.
Yeah. So to answer your questions, there was quite a number there. Where should we start with your questioning?
I would love just like a very kind of behind the scenes view of like, okay, we had all these documents, we
Yeah.
need to organize them, generate the embeddings for them, kind of, and then where did Retool come into that process, that sort of thing.
Yeah, Retool just streamlines all of this process in terms of you have a lot of things that are kind of janky all over the place, and Retool just allows you to bring it all together and use it within one platform, and then also allow people within the institution to use these apps because oftentimes, if you're doing things in Bash or Terminal and you don't have a nice front end for the legal department, they probably won't end up using it. So Retool has come in handy with that. Also, just allowing us to do HIPAA-compliant things by keeping it on our own servers. But with regards to the whole process, I can just talk to you about the policy documents. We manually have to go out and retrieve about 1,052 papers. Once we have that, we process it through Llama Index. It's just a way to index and sort these PDFs so that they are machine friendly and machine compatible. And it also allows us to chunk the documents in a way that once we have a user query, we can bring a chunked piece of information from a large corpora of information, such as 1,052 PDFs, and we're able to retrieve exact chunks of text and bring that back to the AI as context. And that's essentially what RAG is. It's just retrieving and then augmenting your generation. And with the embedding model, we can embed the text that we've brought in, and we can put that into something that's known as higher dimensional space. What that means is that when you have the phrase cat and dog, those two words are quite similar, but the word train is very dissimilar. It's different. So in higher dimensional latent space, cat and dog will be close, but train will be further away. And you can think of that in terms of legal documents. Different aspects of the law will be in different areas of latent space. So when a user query comes in, we convert that to a form that is querying that higher latent space and just bringing in all those little pieces that allows our input prompts or system prompts to run with this new information that is very specific to the person's query. And essentially, you're just giving the LLM more up-to-date information that and more specific information that it can retrieve it from to tailor the output. Retool is a great platform to use for building RAG software. I can't think of anything else that we've used that has been this simple.
Yeah, that's great to hear. Like I mentioned, that's definitely a use case that we focus on, and I think the fact that there are all these different tools out there to do this sort of thing, but there's not really a sort of an application layer to bring all those together, and like you said, make it accessible to folks that aren't necessarily technical and don't want to run a script in the terminal or download some Python script and run it on their machine. It's something that we really strive to make accessible to folks. That's great to hear. Cool. Well, appreciate all those demos. Those were all really interesting. And I think we'll maybe come back to these at the end. I think folks have a couple questions specifically on how some of these things work. But I would love to spend a little bit of time zooming out a little bit and looking towards the future and talking to you about, what are the other kind of high value AI use cases? A lot of the questions we get from folks and some of our customers even is like, what are these AI tools good at? Where is the kind of market going, and what are they going to be able to be good at in the future so that they can plan and start thinking ahead about how they can implement these tools and not get stuck in the sort of pockets of use cases where they're not really performant. So we'd love to hear kind of what you guys have found in terms of really solid use cases for these tools, and maybe some of the ideas for the tools that you are looking to build in the future.
Yeah, no, there's so much we can go with this question. Just to start off with, I think it's important for people to realize what large language models can do and what they cannot do. And I would say the best quote I ever heard was, if it can be done in a Python script, I wouldn't bother doing it with it. I wouldn't bother asking the LLM to try and accomplish that. And what I can give you an example of that. For example, in the toxicology autotox demo that Dr. McCaffrey just gave, you ask the LLM, are these values elevated or decreased or on par with the dosing of the medication that the patient is on? Well, you can also just write down a Python script, arrow up, arrow down, or just neutral. And you can feed that to the LLM while asking the LLM the same question to make sure that it knows that this was a Python result of that same interpretation. So it kind of validates or allows it to make sure that it gets its answer right. So that's just one thing I wanted to put out there, first of all. But some more things with regards to medicine specifically is that we're looking at taking unstructured data like clinical notes, and we're trying to make it structured. And large language models have a great ability to act as natural language processing tools. Python scripts cannot do that. So, for example, clinical notes, when you go to the doctor and you get a note about a 40-year-old patient has attended the clinic with headaches and whatnot, that is very disorganized in the clinical note. It's not machine compatible. It's not AI friendly. And as much as we say that we can bring in data from Epic with Fire API, it's still in a very unstructured format. So one thing that Dr. McCaffrey and I are applying for a grant right now is we are taking taking unstructured clinical notes and making them structured and tabularized for machine learning purposes. That's just one thing I can think of, and I'll give you an example of why that's important. Because right now there are two things in medicine. There's called a progress note and there's called a problem list. And the progress note is what your doctor writes. It's descriptive terms about your issues. Well, the problem list is something that has international classification of disease codes. If you don't have the ICD codes, you can't bill for the patient. And that's important for Medicare Advantage, for example, because a lot of the patients that physicians see at Medicare Advantage are very complex, chronic patients, and they spend a lot of time with them, and they just don't have the time to convert their progress notes into problem lists with ICD coding, if that makes sense. So giving Medicare Advantage physicians the ability to turn their problem notes into structured ICD codes for their problem list would help so much with their billing. That's just one example in medicine I can think of.
So I'm curious with that. Like you're talking about structured output, and I know this is a topic that has folks like struggling with quite a bit. And OpenAI has released their like structured output mode for some of their models. But are you guys using that, or are you doing anything specific with prompting to get that reliable, consistent structured output?
Yeah, so I know that OpenAI plays around with JSON structures with the API now as outputs, which is very helpful. Thank you, OpenAI. But for us, what we're doing mainly is we're trying to build a multi-step LLM process of almost chain of thought reasoning, not to OpenAI's degree, but I would say that you have first AI model that perhaps first large language model perhaps does name entity recognition, just broadly tags what it thinks this sentence is, what this sentence is. And then you feed the same progress note with the name entity recognition tags mapped to the sentences to the next model. And then we can do another step. We can either rerun it and bring it back into another model. So essentially what I'm trying to say is it's a multi-architectural system of LLMs that is just orchestrating from unstructured to structured. And to go from that, it almost is like chain of thought reasoning, and you can break the problem down into however many different ways you can think of it needing to be solved. And just utilizing LLMs at every step, and then also validating the outputs, creating refinement loops, using Python scripts where needed, but it's not really just the idea of having a one-shot prompt is just, it's stuff of legend.
Yeah, cool. I'd love to just kind of, as we wrap up here before we get to the Q&A, talk a little bit about, what y'all are most excited about kind of in the future, some things you see coming. And I know I spend a lot of time on, various, social media and in Discord and nerding out over all this stuff. And I know y'all do too. So as you're like looking to all the new stuff that's coming out and thinking about how y'all can apply it, like what are some of the technologies and things you're most excited about?
Well, first of all, I'm excited for larger context windows. It's going to be cool to have that. The next thing I'm very interested in is just when we went from 4.0 to 4.01 preview, we could all see that there was a massive leap in quality of the way it thought and reasoned. And something I've been looking into quite a lot recently with McCaffrey is bias in medical contexts. Does the LLM ask the difficult questions that a human physician would ask? And 4.0 struggled with that, but 4.01 preview has never gotten a single thing wrong, which I'm very shocked about. And that's just one addition to their system, the chain of thought reasoning. And your mind starts to boggle. Like that is just such a small part of the entire architecture of AI. Imagine how much this is going to get better over time. And also, right now, I'm looking towards a couple of things. First of all, I'm looking at Fire API, which allows me to bring in direct information from Epic. And we have HIPAA-compliant Azure GPTs at UTMB. So we are working actively to bring in electronic health record information direct from MyChart and Epic with Fire API, which would just allow for a lot more reasoning on the back end of perhaps multi-agent systems that discuss your case, that inject parts of your medical information and that bring in information from the internet, that bring in data. And it's just, you can almost facilitate an entire hospital system where every large language model assumes the role of a different department that's fine-tuned on the different department's specialty. My mind boggles with that one. And then the next step is just, I don't know if anyone has heard of this here, but it's called Emerald Cloud Lab. It's a fully autonomous wet lab in Austin. They have something that allows researchers to write in Mathematica an entire wet lab experiment from start to finish. And then the data gets uploaded to the cloud in something called ECL Constellation. And then you can analyze your data with that. Well, I'm interested in perhaps agents, Wolfram agents specifically, that analyze the data, bring that data back into context where an AI model can generate hypotheses. It can generate specific aims. It can generate independent aims mapped to an hypothesis. It can write the Mathematica code. It can execute the experiment. We can give the agent access to a wallet where it can pay UPS to ship the samples. It can run the experiment, analyze the results, and then it can reiterate the experiment. So for the first time, we could have like intelligent systems that plan and execute scientific experiments, and we could almost have, for the first time, dynamic clinical trials on individual patients. Like, imagine it's just your samples that get sent to ECL, and these agents plan, okay, these are the drugs that he's taking. Let's see the levels of expression in his cells of when he's taking these drugs. Let's see if he matches the cohort that was from the clinical trial, or maybe he needs an alternative dosing. And I think medicine is going to become extremely personalized with AI agents and robotics, and that connection is going to be very beautiful.
Cool. And that's really great to hear on our side. Like, what we're really focused on is enabling like this really rapid experimentation for folks to kind of prototype and get things going quickly. And so we've tried to make it as easy as possible to, like you mentioned, within Retool, upgrade models when new models come out, and kind of see how your different tasks perform. And so we're kind of trying to be like the app layer for AI, and it sounds like that's really resonating with y'all. So that's great to hear. Cool. So I think we've got more than a few questions in the chat, so I'd love to get to some of those. I think we're going to start. There's a couple questions from folks about kind of HIPAA compliance, how that worked. Are you just using the GPT model as is? Like, so let's start there. Kind of how did you guys start to think about that? Were you doing your early experiments just on a base GPT model with fake data, or how did that evolve?
Yeah, a lot of what we do is with either fake data, and also we use fake data majority for the Retool as well. Like in the beginning, we did a lot of fake patient data, and then we also have the Azure HIPAA compliant GPTs on our Microsoft Azure account here. So to keep it HIPAA compliant, keep it in-house, fake patient data, and then Azure HIPAA compliant GPTs if you want to start moving towards real patient data.
Okay.
Yeah.
Do you do any sort of anonymization of patient data, or are you just generating kind of fake data wholesale for that beginning like experimentation phase?
We do de-identification of patient data, yes, if we're using real patients. But I believe that when you're using the HIPAA compliant GPTs on Azure, I believe that is the purpose of it being HIPAA compliant. So I guess that would be a question for Dr. McCaffrey, but yes, I do believe we do. Yeah.
Okay. And you all, sorry, go ahead.
The conundrum of medicine is to de-identify is to remove context.
Right.
So yeah, it is quite a battle we face.
Cool. And so when you guys were thinking about that, how big of a factor was the fact that you could kind of self-host Retool, use those Azure models that you mentioned? Was that kind of the thing that put it over the line for you guys, or were you thinking about ways to be able to do that sort of HIPAA compliant work inside of Retool Cloud?
Yeah, I think I have to give all the credit to Dr. McCaffrey. He had the vision before I even got into the MD PhD program. He knew that we needed Fire API. He knew that we needed Azure HIPAA compliant GPTs, and he knew to reach out to Retool, and he knew that we're going to need something to build these RAG apps with. So hosting Retool on our local server, keeping everything in-house. With that, I don't know what else to say, really. Dr. McCaffrey had the foresight for all of that, and that's what allowed us to move faster than I think a lot of other people.
Cool. And do you find like that's where you've gotten the most value out of Retool, is that the ability to kind of move fast and experiment? Is it like the app layer, like the UI building stuff that y'all have leaned into the most heavily, or are y'all using Retool to help with the actual kind of AI building, prompting, all of that as well?
Oh no, we're using Retool for all of what you just said, and also to store our input outputs, and then do data analysis on that later on, like which initial prompt produced a quality output, and based upon human physician validation. But Retool in and of itself is extremely easy to learn and use. I have to say, it's probably out of all the tools I'm using lately, this is quite the most simple to understand and wrap your head around.
Cool.
Yeah.
Yeah, we've got a couple kind of more specific questions here. Nestor says, what is that rank number on the right-hand side of the contradiction tool? I think we talked about this, but maybe just want to go over it real quick again.
Of the contradiction tool for...
Yeah, so where that rank in the right-hand column, yeah.
Yes, so that rank in the top, in the right-hand corner is essentially, once we've discovered contradictions, we feed those contradictions back to an LLM, and we say, okay, based upon all of these contradictions, rank which ones would be from 0 to 10, and we defined like 10 being catastrophic for legal department and 0 being like, oh, we can get round to it never and it'll be fine. So the LLM at the end of the whole pipeline ranked it. And like I was saying earlier, we tried to bake that into the initial prompt where we said, find contradictions and rank them. But we found that through using Retool that it wasn't a good method of doing it. It was rather find the contradictions and then have another model that ranks it based upon predetermined criteria of what is considered very bad for the legal department at UTM, and that is something that the legal department has helped Dr. McCaffrey with in the ranking. I don't know too much about the ranking, if I'm being honest, because the specific criteria was worked out with the legal team.
Got it. Cool. And so just diving into that maybe a little bit deeper, folks have a couple questions. I'm kind of combining a couple here of like, was Retool used for the actual kind of RAG implementation? For some background for folks, we do have a product called Retool Vectors, which lets you kind of host a vector database inside of Retool and embed your documents in there and query those directly. So I think there's a question from folks of like, is that kind of how you guys did that? Or, you mentioned Llama Index. There's a couple questions there too. So would love just kind of a high level, maybe like building blocks, sort of like, here's our PDFs. They go into this tool. Retool queries them in this way. Just kind of how that works.
Yeah, so I don't believe that we stored our vectors within Retool itself. I think we perhaps used Pinecone or ChromaDB. I can't remember exactly which one we used, but essentially we have all these PDFs. We process them through Llama Index. Once they've been in a indexed format, then we vectorize and embed those into the model. So when we have a user query, it's just also being vectorized and searching within that latent space for cosine similarities, specifically finding those nearest matches, bringing that information relevant to the query back to the model to then have context for the prompt. And Retool just kind of facilitates the storing of everything. And it allows them not to have to use like janky terminal things. These lawyers could just use our in-app where the query gets sent off and then we bring all that information back. So the model is that the vectors aren't actually stored on Retool, but we can do that. We just didn't really want to learn another tool, but we can definitely learn that going forward. Yeah,
for sure. So kind of maybe zooming back out a little bit to a higher level question. Eric asked, how do you manage such a complex multi-prompt and pipeline like in Retool? Like, do y'all have a dedicated team of developers, or like, what's the team look like? Because y'all have, been talking about a very, very high level stuff and a lot of implementation details. And I think there's some questions of folks like, hey, like, where are all the developers behind the scenes, et cetera?
Yeah. Well, me and McCaffrey made the AutoTalks in 5 weeks together. So right now the team is me and him, and then we have some physicians, lawyers that are validating outputs using this, helping us refine everything. But for the most part, it's just been Dr. McCaffrey and I. And that honestly speaks to how good of a tool Retool is. I'm not speaking to how good of a team we are essentially, but Retool is a very, very user-friendly platform.
So you found that you've been able to basically use Retool to get something up and running quickly and then iterate with the end users, whether that's, lawyers or other physicians. And you haven't needed basically a huge dev team to get that off the ground. Is that basically what you're saying?
Yep, that's exactly what I'm saying.
Cool. That's awesome. That's great to hear. Like I said, that's kind of our goal, and that's how we, hope to enable folks. So that's awesome to hear that's working the way we want it to. Cool. Another question. I think this is maybe one that I can take. Is there a way to use AI to retrieve data from a table rather than retrieve data from a document? So the answer in Retool specifically is yes. There are a couple tools that you can use to do that. Like I mentioned, Retool Vectors is a way to kind of take any sort of data that you want and have embeddings and then query that and use it for the sort of retrieval augmented generation we're talking about. Also, because of the fact that, databases, RetoolDB or whatever database you want to use are just resources in Retool, you can use queries inside of your Retool app to just pull in that data and use it. If you just want to query the structured data, right, you might not need the sort of retrieval augmented generation we're talking about here, but you just want to include that structured data as context into your query. And so the fact that Retool can bring, structured data in a database or unstructured data in a vector database, like any kind of data you have together is one of the things that makes it so powerful for building essentially any type of app you can think of. Cool. So just a couple more here. One of them is, this is a little bit, we kind of skimmed over this, but can you list all the tools used one more time? The only one I caught was Llama Index. So maybe just a quick kind of overview of some of the tools that you found helpful. I know you've also mentioned Pinecone and some others as well, but that might be helpful for folks who are taking notes at home.
Yeah. So some things I would offer advice on. I would say Llama Index for indexing your data. Then I would use OpenAI's embedding models. They seem to be the most useful at the moment. If you want to have complex LLM architecture one after the other, where you feed outputs into the next and whatnot, I would look at LangFlow and LangChain. They're very helpful in kind of, instead of having 50 million browsers pulled up, you can actually start routing things as they go along. For your vector database, I would suggest Pinecone or ChromaDB, like I said. And then for your model specifically, I would say play around. I think people underestimate playing around with which large language model API they use. I've found a lot of use cases with smaller models like Mixtral, or even some of the Llama 70 billion parameter models. Like these, you can fine tune them on tasks, and they're actually very accurate and precise on what they're doing. So, yeah, and Retool, of course. That's the other one.
I think speaking to your last point, like that's one of the things that I've personally, I build a lot of different AI apps in Retool. And one of the things that I'm always surprised about is like, once I get a prompt that's kind of working, but it's not working quite how I want it to, I'll just like go and hit that model drop down and go pick a different model. And the fact that I can just very quickly like see, what sort of outputs come from different models has been really interesting. And we actually built a tool where there are 4 kind of text boxes on the screen. You put your prompt up at the top and it will do one, GPT-4, one Claude, one Google Gemini model. And so you can really quickly kind of see the differences. And I do agree though, that's something that folks get kind of locked into. Like I only use GPT or I only use Claude. And it's like the models do have their own kind of idiosyncrasies, and experimenting with them is something we've really tried to make pretty simple for that reason. Cool.
Yeah.
Awesome. Well, that was super comprehensive. That was very helpful.
Thank you.
So cool. I appreciate you jumping on and walking us through this. It's really kind of on my side, selfishly, like great to hear that Retool has been able to kind of unlock all of this for y'all and help you move a lot quicker. It's kind of the app layer on top of all your AI experiments, and not only experiments, but things you are actually shipping to production. So any last thoughts or places where people can go to learn more about what you guys are doing?
I would say not about what I'm doing, but if you want to learn, I would say there's a man called Andre Kapathy, and he's on Twitter, and he's helped me a lot with what I've learned. So shout out to him.
Cool. Yeah. Great. Well, thanks again, James, for joining us, and Dr. McCaffrey as well, even though we had to jump. It's great to talk to you, and we hope to maybe have you back again in the future.
I hope so. Thank you so much.
Thanks.